Okay, so there's a couple more examples of games from last year. So last class, we left off and we were working on this missile attack type game, some clone of that. Does anybody have any questions for me before we start today? No. Yep. You'll have 1 week, but you know what the assignment's going to be, so yeah. So I can. The assignment text is almost the same as that of assignment 3, except it's graphics. There's a list of requirements, but they're things like should have a soundtrack, sound effects, all of these things. The game should get harder as it goes on, and so on. Any other questions? Anybody doing assignment 6 now? How's that going? Good, good-ish. Anybody really, really stuck? Can't even get a window open? No. Technical problems are getting resolved, I hope. It seems like the Mac people know what to do. So there were some issues there, as well as so Mac OS seems to be a major annoyance for some of this Pygame stuff. Eventually you can get it all to work, but it's not obvious sometimes. So keep helping each other out on the forums. So last class we had worked on this game, some missile attack clone, and we had gotten to the point where we could shoot missiles, so we could launch them by clicking on the screen. We had these incoming missiles, those were easy to do, and we had even gotten basically not collision detection, but when a missile explodes, it also blows up any other missiles in the vicinity. So I did a little bit on that just before class today. I added a background image. I added a soundtrack. I'll call it a gun, but it's not a gun. It's actually just a picture of a dome, but the missiles now come from there. And one thing that I noticed is the game was a little harder than I would have liked. So I made the outgoing missiles a bit faster and the incoming missiles a bit slower. So background image is easy. For that, you just load the background image when you initialize the game, and rather than clear the screen, setting it with a straight white background, you draw the background image at the top of the game. So in the draw loop, the first thing you do is draw the background, because everything else you're going to draw is on top of that. So that's the background image. The soundtrack, that's also quite easy to do once you find the soundtrack you want. So I went and got a loop wave file, and when the game gets initialized, you create this. You open this sound. You set its volume to something less obnoxious than full volume, which is the default, and you play it. And this play argument takes several optional. This play command takes several optional arguments. One of them is the number of times you want to play it. And here I want to play it -1 times, which is code for play it forever. So not just once, not just twice, but forever. And I went and got this thing off of a site that specializes in loops. So it's a short clip, but it ends exactly at a point where it picks up again. So it sounds like it's continuously playing, but it's really just repeating the same thing over and over again. The gun is also quite simple. It's at to make that work, you have to if you're going to draw it as a picture, so get an image of a gun from somewhere, or whatever you want to call this thing, a cannon. And first load it when you initialize so that you have this image ready. And we've seen, and you've now, many of you have already done, drawing of images. So draw it, and we draw it in the middle of the screen on x coordinates. So that's centered in the middle, left to right, but right at the bottom of the screen. So just so the bottom of the image lines up with the bottom of the screen. We draw that there. And speeding up changing the speeds of the missiles was also quite easy. Remember, there's two classes of missiles. There's just missile, which is what gets created when we fire a missile. So when we initialize one of those, we set its speed to 8. And then there's a subclass of that called incoming missile, that when it gets initialized, well, it gets initialized the same way as all the other missiles do, all the other stuff does, but we change its speed to 4. So it's half the speed. Yep.
Is there something with gravity?
No, you have to simulate that yourself. But gravity is a fairly easy thing to simulate. What gravity wants to do, so if a object is traveling along a vector, that vector has an x and a y component, and gravity affects only the y component. It's dragging it down. So it's always decreasing the y component. So every frame, the y component of the vector should be decreased by a constant amount. Okay. So let's see what this thing looks like. Oops. So background image, little dome at the bottom. Oh, and there's a score as well. Missiles come down, you shoot them, and you can shoot a lot faster. Your bullets go significantly faster than the incoming ones. I'm not sure how well you can see things there. Do the blue guys, the incoming missiles, show up okay? Hard to see? So let's change them. So we'll change their color to straight green. Better? Still not super easy. Okay, so right now there's just these missiles coming down. We're able to blow them up, but we're not really defending anything, and they're just coming down at random. Really, this game is about defending your bases, so we need some bases. So we'll want to define some class which implements this notion of a base. So that says we're going to make a new class called a base. And what kind of properties does a base have? Health. Okay, so a base will have a health. I don't know, can start at 10 or something. What else? A location or a position. So we'll initialize it at a certain position because we'll probably have more than one of these things, and it'll have a health. By default, they start with, I don't know, 10 or 100% health. And okay, that's good. So we want an image for these things. So all bases will look the same. So there's a PNG file called base.png, and was game.image.load. okay? So we will have that, and we, like other game objects, missiles in particular, this thing should probably be able to, these bases should probably be able to draw themselves. So you give them a screen and they'll draw themselves on the screen. And I'm going to go with the convention that the, remember the screen looks like this rectangle, we've got this gun in the middle at the bottom, and the bases are going to go here and here. We'll have two of them. And the position will be, let's say, the position of the center bottom of the base. So this will be the position. So I want to draw these things on the screen, drawn that way. So remember, when we're drawing pictures, this rectangle is just a rectangle with top left corner 0, 0. That's the width and height of the picture. And to draw it, we move the rectangle to where we want it to be on the screen that we're drawing on. So in this case, where do we want to move the rectangle? So where do we want this, or to what coordinates do we want to move these rectangles so that they line up like this picture here? So what should the x coordinate be? Yep.
1/3 the width of the screen.
Sure. Let's say 1/3 the width of the screen. So that would be. Well, no. I mean, we want to move them to their position, right? So this position is this thing. We want to draw them like this. So where do we move the rectangle in that case? So the rectangle currently is, you can think of it as being up here. It's got this house. We want to move this thing right to there. So. So what's the x coordinate and what's the y coordinate? This thing is, position at 0, position at 1. So is that, do we just say rectangle dot move self dot position at 0, self dot position at 1? What will happen if we do that? Yeah. If we take this thing and we move it to here, that means we're taking its top left corner and moving it to here. We're going to draw it completely off the screen down here. That's not where we want it. We want it here. So we can fix the y coordinate first. And we do that by subtracting the height of the rectangle. So that will move this thing up here, which is still not quite right. How do we fix the x coordinate now? Yep.
Half the width.
So subtract half the width of the image. Okay, so we move that thing to there, and we finally screen, we blit the image into that location. Good. So at least now we have this, we've created this base object, and these bases can draw themselves, but now we need to incorporate them into our game. So when we initialize the game, which happens here, is where we set everything up, what should we do at this point? At the start of the game, what do we need to do? Create the bases. So we've been using a list to keep track of missiles. We might as well use a list to keep track of bases as well. And we'll create a couple of bases. Their locations will be, well, like in the picture here at the bottom of the screen. So we want, let's say, I don't know, a third or a quarter of the width. And right at the bottom of the screen, so that's the height. So that's one of our bases. And our second base will be at 3/4 of the width. Okay. Now what? So is it going to work now? Yep. Nope. We've made a routine for drawing it, but we never called that routine. So we'll just test our code for errors. So it seems to have successfully created the bases, at least without crashing, but they're not getting drawn. And to draw them, well, that's what we do in the draw function. So we're already drawing the gun, we're drawing the missiles, so we want to draw the bases in there. And we should think about where we want to, where do these fit in? So keep in mind that we're sort of painting a picture here. And so the order in which we paint things matters, because other things can, things that are drawn later get drawn on top of things that are drawn earlier. So bases, should we draw them before or after the missiles? Yeah. After. Let's try that. Okay, good. So there's our bases, right where we wanted them. They look kind of cute, I guess. All right. So we got our bases. So check mark on that requirement. Well, right now, the incoming missiles, they just sort of come in randomly and shoot all over the bottom of the screen. If we go and look at that, we can see that happens here. When you launch an incoming missile, it basically picks a random coordinate from the top of the screen to start at and shoots to a random coordinate on the bottom of the screen. These things should maybe target the bases a little more carefully. So what should we do? How do we do that? Yep. Sure. So let's fire a missile at one of these two bases. So for that, we would say something like target base is random.choice from self.bases. We'll try that. And then the target will be target base dot position. So let's see if that works. So it looks like those two guys are headed for the bases. Indeed, those two as well. Now, anything unusual here? Anything that we don't want? Yep. Sorry, what's that? It's going behind the image. And that's because we draw our missiles first, and that includes the explosions of the missiles, and then we draw the bases. So indeed, we draw the missile and the explosion, but then the base just covers it up. So we should maybe not use that ordering, and maybe go with bases before missiles. And we'll get something maybe a little more expected. Okay. So, so far, so good. Maybe we should make these missiles, I don't know, slightly less accurate. So one interesting thing happens there is even though all the missiles are supposed to explode right at the bottom of the base, some of them run into previously exploding missiles. Yep.
Three-dimensional game, should we always have the effect at the forefront? Because if you think of it three-dimensionally, it could be made behind the building, for example. Should we always try to bring all the effects to the front?
It depends exactly what you want to accomplish in your game. Here, I think, you know, you always want to see all the moving things. So the missiles probably should be the last thing that get drawn. Explosions are somehow important too. So that's why I would do it that way, but whatever. I might randomize this a little bit and say when we target one of these missiles, maybe don't aim it exactly at the at that position, but let's say give it a little leeway and maybe do the same thing for the y-coordinate or something similar for the y-coordinate. So target base position at 1 minus. Let's try that. So now they don't come right necessarily all in exactly the same spot, but they're slightly randomized. Still headed for the bases. Okay, good. So now we've knocked that off. Incoming missiles aim at the bases. Now we want them to somehow damage these bases. So what, how are we going to make that work? Where do we do that? Yeah, so we've already got some code in here that we did last class that runs this, you know, frame by frame update of making the missiles move, checking to see what's blowing up, seeing if any more missiles are blowing up because of other missiles that are blowing up. So we can include that there. So now what we want to do is check missiles versus bases. So we already have a list of exploding missiles. And a list of bases. There's only 2 of them, but still easier to iterate over them. And now we want to check if this exploding missile is hitting this base. So what does that look like? So in our picture, this exploding missile has a position and the base has a position. This is what the position of the base is. It's at the bottom of the center of the base. And you know, there's this exploding missile whose position is actually right at the center of that explosion. So I don't know, how do we check to see if these things are, if the missile is hurting the base or not? Yeah.
Do the missiles blow up at a certain point when it hits the building?
The missiles blow up when they reach their target, and their target is chosen when they're launched. So it's not when they hit the building, it's when they reach their target. And you can see that, I mean, you'll watch them go, they'll actually go into the building for a little while, and then they explode. Yeah. Okay, so let's take a look at so this explosion.png is a let's say roughly 80 by 80 image, and so that means that it's sort of like a circle of radius 40. So if the distance between the explosion and any part of the image is less than 40, that should do it. So that's the kind of thing we want to do. Unfortunately, our image of our bases is kind of irregularly shaped, right? So there's a couple of ways we can deal with that. I mean, we can carefully craft a routine which checks, you know, basically breaks down the image into a couple of rectangles, and sees if that works, and you know, checks, you know, just does a bunch of cases to check if the explosion is close enough to any part of the building. I don't really feel like doing that, and the reason that I don't is I'm not super happy with this image anyway, so I don't want to spend a lot of time writing code that's only going to work for this image and doesn't work if I change it. So we'll just cheat a little bit, maybe do a cheap version of collision detection that we can tidy up later. And you know, really cheap is something like if the distance from B's position and the base's position and the missile's position, if that is, let's say, less than, so that's measuring this distance here, so I don't know. Maybe if that's less than 80 or something, we'll call that a collision. Okay, so that says that we want to then do something to this base, damage it, reduce its health. So we could just say something like, you know, base.health equals base.health minus 1. That's an option. But I'm not sure if that's such a good one. And, well, the reason is that, well, maybe the base wants to do other things when it gets hit like this. So we're going in and we're changing this property of the base down here in this other class. And, you know, maybe when the base's health gets reduced, something changes. Like, you know, maybe the image changes to look like the thing is damaged or it turns gray or something else. So let's leave it up to the base to decide what to do. So we'll say something like, tell the base that it has taken a hit, and then define what that means for the base itself. And maybe we'll even say where that hit happened. So we'll want to reduce the health, and we'll want to be a little bit careful here. So I'll reduce the health by 1. And so let's see, we'll do a little bit of debugging at the same time. We'll print the health of this base. Yeah, we'll have to do something. So let's see if this works. And it also works, doesn't matter what kind of missile. So, all right, take hit. We forgot to tell it where it was hit. And that was the missile's position. So let's shoot our own missile at this base and see what happens. So the base health dropped from 10 down to -6, or 9 to -6. Why? What's that? Yeah, because the missile, remember, this explosion happens over the course of half a second, and looks like a little more than half a second, 16 frames. And so this advance or update thing gets called every frame. So, you know, this thing explodes, and for the first frame it checks it and says, okay, this missile is exploding and it's in the base, so we should, you know, the base takes a hit, and then it checks it again and checks it again and checks it again 16 times. So the base actually ends up taking something like 16 hits. What could we, how can we deal with that? Get rid of the missile at this point?
You could create a variable inside the missile that says if it's hit anything.
Well, we already have a variable inside the missile that does something. So remember, the way we got this missile to even explode nicely is we set its state to exploding, and then we started a counter. And it's that counter that runs up to 15 or 16, or gets incremented 16 times before, before the missile, the explosion just disappears. So I think if we do this, we can just look at the counter and say, well, if the counter is 0, this is the first frame where this missile exploded, then we should count this as damage to the base. After that, it's just there for show. Yeah?
Can you also look out for dealing damage to the base inside of the explode function?
Well, the thing is, missiles, in our object hierarchy, we have this missile class, and we have this base class, and those two classes don't really know about each other. They're all coordinated by the game itself, which knows about missiles and bases and decides when a missile is exploding close enough to a base. In general, when you make these class hierarchies, you don't usually want classes that know about each other so much. So one class somehow controls the other ones, but you don't want missiles knowing about bases and then bases knowing about missiles, because you create this big reliance on things that's very easy to break if you change anything. So it's probably easier to just keep the control happening up in the game class, because it knows about both of these things. So let's say we'll only do this damage if this counter is 0. So we'll check. So what happens? We update the missiles. We will now check to see if any missiles are exploding close enough to bases. If so, and this is the first frame for which the missile is exploding, which means its counter is equal to 0, then we'll call that a hit on the base and tell it to take a hit. On subsequent frames, when the counter is 1, 2, 3, and so on, that's not going to happen. So let's blow one up. And indeed, the health of the base. Drops and goes down to, eventually goes negative. Okay, so now what? Yep.
What happens there when it went from 1 to 7?
That was a different base. So that was a different missile striking the base on the left. Yeah. So this is the one that was steadily decreasing is the one we were shooting at, but eventually another missile got to the other one which printed it out. Okay, so now bases take damage, and they just keep taking damage, till their health goes arbitrarily low. When should we stop this and do something else? Yep. Yeah. So let's say when the base's health is 0, we might want to change something about this thing. And I don't know, maybe the easiest thing is to change the way we draw it. Somehow indicate that this thing is, this base is dead. So dead, for that, I've got an image for that. It's in crossbones.png. So we draw the base, and then we'll say if the base's health is less than or equal to 0, we'll get this crossbones and draw it on top of it. Let's call it. So this is a new image that we haven't used before, so we have to be sure to load it once at the beginning.
Why don't you just take the value of image from the skull?
You could, well, image is a shared variable, shared across all instances of this class. So if you changed it, then both bases would suddenly get the image of the skull as their image. So that's one reason. So you could instead make image be local to this class, in which case you wouldn't define it this way. You would create it inside of init here. But I'd still like to see the base, but just show that it's dead somehow. You might, you can do different things, but this is the way I would like to treat it. And that was crossbones.png. See if that works. There we go. So indeed, it shows up as dead once its health goes down to 0. All right. So missiles aim at bases, missiles damage the bases. In fact, the bases disappear. We're already keeping a score. We want increasing difficulty. Maybe something else that's maybe useful is some indicator of the health of the bases, so how damaged they are. Any obvious ways we could do that? Health bar is a standard thing. Usually you see them on the top of the screen or something. Any other ways? Yeah. Yeah, so you can do health bars above or just really close to this thing, to the base. Any other options? Yeah.
Yes, you could draw a new picture with the base slightly damaged and then hit it as the base help gets lower.
Yeah, so if you had a whole sequence of images of worse and worse bases, you could use those. I'm a bit lazy to create those.
Add some fire to it.
We could also put something visually right on the image to show where it was hit or something. So fire something. So let's try and do that. A little touch of something a little bit extra fancy. So when you take a hit, your health goes down, and so maybe, and this is where you'll want to indicate this or keep, somehow indicate where this hit happened. So let's see if we can make this work. So we'll say. So when we create one of these things, we'll have a list of all the fires that are taking place. And we'll say, when you take a hit, we'll say self.fires.append, and we'll or not even a list. We'll save the position where this fire took place, where this explosion happened, where it got blown up. And now when we draw this thing, we'll want to show these fires. So let's see if we can get that work. Well, the cheap way to show a fire is as a little red dot. So let's try that first. For F in self.fires. So we want to draw a circle at F, and I need to remember what the arguments to draw a circle are. Okay, the surface, the color, the position, the radius. Okay, so the surface is the screen that we're drawing on. The color will be, I don't know, red. That's red. The position is the location of this thing, and the radius, we can experiment, let's say 10. See if that works for us. Oh, and I forgot, circles do not like non-integer arguments. So we say f equals int x for x in f. So there's some crappy looking effects. And we see that some of our collision detection is not excellent either, right? This tower here is somehow indestructible. And that's just because we're not counting that as a collision. So that's something we'd want to tidy up. This strategy seems to work. Maybe the circles could be a little bit nicer. So let's change those to some kind of flame. Flame.png. Again, every time you want to use a new image in your game, you should load it at some place where it's only going to be loaded once. And so that's there. And now rather than just draw a crappy circle, we'll draw a beautiful flame. And I think probably the best way to do this is to have the base of the flame be where the explosion happened. So let's do that. So we want to move the rectangle so that its base is at position F. So that would be the x-coordinate is F's x-coordinate minus half the width of the image. And the y-coordinate is the y-coordinate minus the full height of the image. Try that. Good. Still crappy, but it leaves us the possibility of drawing some custom art that doesn't look quite so bad. And indeed, you really see these buildings now are going up in flames. There's a pretty decent indicator of their health. But if that's not enough, we can still even include a health meter. So a health meter is usually a bunch of, like a bar or something. Even better is something you can count. So I don't know, a cheap way to do that is to do a bunch of letters. So let's try that. So at the top of the screen, we want to draw the health of each base. So we can actually do that using text. So for each base, we'll create a string which shows us its health. How do we do that? How do we turn a health number into a string that looks like a health bar? Yeah.
Just make like a little vertical bar for each point of health you have,
Yeah.
and then you can move them as you go.
So what's a vertical bar look like in text?
It's the key above your enter key.
The key above your enter key. Sure, we'll try that one. So we will render the string, which is vertical bar multiplied by health, which is an integer, so that should give you a string of exactly that many of these vertical bars. We would like to be anti-aliased, and well, we'll render it in some color. Maybe the color can even depend on the amount of health. For now, we'll try white. And we want to draw this thing somehow over the base that it corresponds to, and so that's pretty easy. That means we want it to be positioned with its x-coordinate centered over the base's x-coordinate. So that's B's position at 0 minus the width of the rectangle divided by 2. And the height is actually just a little bit off the top, which we've given a name, top pad, for top padding. See if that works for us. Good? Ish. Maybe the font is a bit too big. I don't know. Is it decreasing? So indeed this thing is going down. We are going to run into a little issue once we actually get a score that could eat into our area for these things. So maybe we should use a smaller font size. And for that, we'll just crank the font size down to from 60 to 40. Okay. All right, so incoming missiles damage the bases. We keep and we show a score. We show damage to the bases. Increasing level of difficulty. How would we manage that? Yep.
Missile speed increase,
So we can increase the speed of the missiles. Anything else we could increase?
less health.
Less health. That sort of happens over time anyway.
Well, I mean, it's like sudden death, but less, you start with less lives.
Sure. So you could have, that sort of suggested maybe there's levels that you get to the next level, and then in the next level your base is only half as strong or something. Yeah. The frequency of missiles, yeah. So frequency of missiles, the speed of missiles, maybe even the strength of the missiles. So you could mix in some bigger ones that do more damage. Yeah. I don't know that changing the size of the missiles will do much, in particular because of this mechanic that we're using, that the explosion, if it's close enough to the missile, kind of blows it up. But you could make tougher missiles, ones that you have to hit more than once, for example. Yeah. Yeah. So missile that blows up. Yeah.
A missile that splits into 3 missiles halfway down the screen.
Missile that splits into 3 missiles halfway down the screen. Sounds good. Although 3 missiles is unclear if that's helpful, because what are they going to do?
It's complicated to code.
Okay. All right. So that's the challenge then, to do a splitting missile. All right. Let's try it. So we won't make the game harder just yet, but we have a challenge now, which is code a missile that splits itself into, I'll say 2 because there's only 2 bases. If it splits into 3, then 2 of them are going to have to go to the same base, and they'll sort of be on top of each other. I mean, we could code our way around that too, but this will be good. So let's call this thing a splitting missile. What kind of missile is a splitting missile? It's a kind of incoming missile, right? Okay, so it's a kind of incoming missile. Maybe we'll give those a special color. Oops. yellow. Speed will be the same as before, and we'll initialize them pretty much the same way. Super incoming missile self, except that this is a splitting missile, and it'll just get initialized the same way as its parent. Okay. So what's different about an incoming missile is that at some point it decides to split into two missiles. Or not an incoming missile, but rather a splitting missile. So it decides to split into two of these things. How are we going to manage that? Or when are we going to do that? Or who should do that? Yeah.
You randomize which person does it, and then you create two missiles at the point that go off in different directions.
Okay. So this is interesting then, because a splitting missile, it's really just this thing all by itself, right? It doesn't, I mean, if you say, if it decides it's time to split, then what does it really do? It's still just this one splitting missile.
Creates two new missiles.
So, well, it creates them, but creates them and does what with them? Somehow it's the game that's controlling all of this. Yep.
You have to just create one extra missile that starts at its point and goes to the opposite base.
You can create one extra missile that starts at that place and goes to the opposite base, but it's not clear that that's actually the splitting missile's job versus because to create an extra missile means to create it and put it in the game, and it's the game that's keeping track of all of these things. So maybe it's actually, this whole splitting missile thing should be something that the game does. So let's take let's maybe rethink how we'll do this. So we'll leave this splitting missile class here for now in case we need it. But let's go to this update thing, see what's blowing up, check missiles, draw. Here's where we launch new incoming missiles. And maybe this is where we should split missiles. Instead of launching a new incoming missile, maybe this is just another way to launch an incoming missile. It's just from an existing missile. So let's try that and say gather up the incoming missiles. So we'll gather up a list of incoming missiles. If there's any incoming missiles, and with some, I don't know, random chance, we'll do a split like this. I don't know, how often should this happen? Every 2 seconds again, roughly? Yeah. Well, so basically by doing this kind of random coin toss, so the way we launch missiles currently is we toss a 60-sided coin or dice, and if that coin comes up on one special side, then we launch a new missile. So since this happens 30 times a second, we expect then this will happen about once every 2 seconds we'll get a new missile created. And we can do the same kind of trick with this splitting. So I don't know. Well, this is something you'd have to play to figure out. But we'll try the same thing. Every 2 seconds or so, an existing missile will split into two. And now we should, this is actually getting into something really interesting, because if we start to, if we want to analyze this carefully, well, think about how long a missile takes to get to the ground, because basically if we launch even one missile, and then that one splits into two, and then those two end up splitting into two, and then those two end up splitting into two, we could end up with something pretty crazy pretty quickly here. So let's give it a try. All right, so if there's some incoming missile at least, and this coin toss comes up lucky, then we'll say M is, pick a random incoming missile, and we'll say self.missiles.append a new missile, a new incoming missile. Its position will be M's position. So it starts at the same location that the current missile we're looking at is at. So that's its starting location. And its target should be the other base. So we have to figure out how to get the other base. So that would be if M dot let's see, if M dot target, this is really hacky now. I would clean this up better if I was doing this. Well, I probably will clean it up after class. So if it's targeting the left side, which is the base at 0, so if it's the left side of the screen, then what we will target is the right side. So that would be self.bases at 1 dot position, and otherwise let's try that. Missiles is not defined because it's self.missiles. Where did I not define it? 216. So now we just have to sit and wait for one of the, oh, there it is. So the moral of the story is kill these things quickly because they split rather quickly. So already that split. Okay, good. So there you go. You asked for it, we did it. All right. Back to making the game harder as it progresses. So we've got splitting missiles. We've got missiles that come with some frequency. So basically, one of the cheapest things we can do is to speed up the frequency that these things arrive at. So rather than tossing a 60-sided dice, let's make them arrive faster by by just making it more and more likely that they will arrive. So let's go with, I don't know, 60 minus the score over 100. That'll get fast, really fast. And we can even do the same thing with the splitting. So now we need to rack up some score to get this to go faster. So now every 45, about half of 45 frames or so, we're getting one, so that's more frequently. Now they're really up. So some bug in there somewhere. I don't know if you noticed there was one unintended game effect there, which is the cannon becoming useless. If you blow up a missile near the cannon, then that explosion stays there for the next half second, which means anything else that comes out causes another explosion, which stays there for another half second. So you can really, your gun can jam this way. Just a side effect of the rules. Yeah. Yes, I got frustrated with the pad. Let's maybe see if we can just spot this bug in line 191, empty range. So that means that I got my score over 6,000. So basically, there was a missile coming every frame. So I won. That's basically the best that I could do before this game crashes. We could clean that up by saying it's the minimum of 1 and that thing, or not the min, the max. Yeah, you do get that happening. Where did I mess that up? Thanks. Sorry, what's the if? Okay. Yeah. So let's see if this thing is actually even playable at that. So you may be able to put it into a state where you have enough, as you pointed out, enough explosions happening near the top of the screen that nothing ever gets down. What's going on at the bottom is there's guys going, missiles shooting back and forth between the two bases and splitting off and going back to the other base. So the bases are long dead. But now you don't have to do anything, right? You just take your hands off and watch it play. And this is actually a kind of volume. It's kind of an interesting thing. So what we seem to have created now, rather than a game, is just some kind of simulation, right? Now we don't have to do anything. Once you get it going, it just does it itself. Score is going up. I'm doing great. Of course, the game should really be over at this point because both bases are dead. The enemy doesn't seem to care. They're ruthless that way, and they send it all over. Okay. All right. So there's still some playability issues for sure. But let's say we just want to turn this thing into something that looks like a game. What should we do next? Yeah, so we should probably end the game once both the bases are dead. So this is actually something that there's a lesson to learn about these kinds of things. Games typically have the form of what's called a finite state machine, something you'll hear about later on in your academic career. But they're easy to understand. So a typical game looks like this, right? There's a, well, if it's a crappy game, there's a load screen. And then once that's done loading, there's something like a press start to play screen or click to play. Then you're actually in the game proper. So that's what we've been making here as the game proper, but none of this other stuff surrounding it. And then eventually there's a game over, where the game ends and you get to look at your score and whatever else. And after that's been there for a while, you maybe go back to the press start screen. Or maybe the loading screen if it has to reload stuff. No, you never win a game. There's no such thing. No good game has a win screen. At least not, arcade games don't have a win screen. They'll go as bad as just starting over without doing anything, right? Score back down to 0, start over from the first level. Yeah.
Should we put in a load screen just to make the game seem better than it is?
Yeah, that's a very common trick, is using a load screen, loading, and with lots of little messages, loading graphics, loading sounds, lots of updates, even though the game, is tiny. So it's a good trick to make a game seem better than it is. But the way you implement this is exactly as what's called a finite state machine. You just give your game a state. So we might have this starting state, the playing state, and the game over state. And so we'll just get one of those done, and I'll do the rest offline. But the game over state is probably the most interesting, or the one we need to really make this look something like a real game. So we'll start out, no load screen, no nothing, you fire up the game and it plays. And so then when we refresh, if the state is playing, we update all the action. Otherwise, we don't. And then finally, when we draw, If the state is game over, we need to draw the game over text. So we render the string game over, all uppercase, at least 3 exclamation points. Like that. And when do we go into the game over state? That's during an update. If self.basis at 0, health. Where are we? $265. Okay, let's end this game as quickly as possible, which turns out to be not that quickly. Line 204 in update. This is one of the difficulties with debugging games. Not particularly hard to get to the game over screen usually, but for some of the harder levels it can actually be difficult to know if they work because you actually have to play through them.
Can you just make the code the same for all levels?
Well, I mean, it depends what kind of game you're making, but sometimes levels are really different from each other. Okay, game over, good. So now it's in the game over state, everything stops at that point. You'd usually play some really awful sound to make the user feel bad about themselves. So we got somewhere this time.